Hi, welcome to Chapter 10, Section 7, Areas of Circles and Sectors. There's a couple of formulas you're going to need to know for this section. The first one is the area of a circle, which I believe we've looked at before. Area equals pi r squared. I know you're saying the old joke, pi r round, ha ha ha. Okay, second new vocab word, sector of a circle, is going to be a section of the circle bound by a central angle and an arc of the circle. If you look below, we have a sector, which again is basically just a pi wedge, okay? So sector of a circle, let's make a note up here. It's really just a pi wedge. Okay. The formula for the area of a sector, the one that you're going to want to memorize, is that the measure of the arc, the central angle, times pi r squared. Central angle is the arc. So if this happens to be 90 degrees, then to calculate the area of this sector, and we would call it sector ABC, to calculate that, we would do our central angle, which is 90 degrees, which is also our arc measure, over 360, times pi. I don't have a radius here. Let's go ahead and say that radius is 10 for argument's sake. So pi 10 squared, and then we would just go ahead and multiply that out. Most of the time, you're going to leave your answer in terms of pi, meaning you won't substitute 3.14 or 22/7 for pi, you'll just leave it. So this is 1/4 of 100 pi, which is a final answer of 25 pi square units. I don't know if these are centimeters or inches or whatever, so we'd leave it like that. Okay, we're going to move on to page 2 and do a couple of examples. Okay, on page 2, we're looking at example 1. We have a central angle AOB, which is 60 degrees. So I'm just going to go ahead and draw in what I think is a 60 degree central angle. And of course, if this is 60 degrees, that means my arc is 60 degrees, the measure of it. The radius here is told to us to be 9 inches. So we want the length of the arc, and we also want the area of the sector. Okay, so the length of the arc, I'm going to call it L, is equal to, if you recall, the central angle over 360 times the circumference, which is 2 pi r, and our radius is 9. So we go ahead at that point and we just clean up. So 1/6 of 18 pi gives you a grand total of 3 pi, and this is length, so the units will be inches. For the sector area, we use the same central angle, except this time we multiply by the area of the circle, which is pi 9 squared. And then we go ahead and we clean that up. So 1/6 of 81 pi, and we reduce that by 3's, which gets us 27 pi over 2. And our units would be square inches because we're dealing with area. Okay, let's hop down to example 3 at the bottom of the page. The sector is AOB, and its area is 7 pi over 2. And angle AOB is 315 degrees. That is huge. So 315 would be AOB. That'd be this giant part here. Okay? So this giant part is 315. The sector that I'm looking for, that I have the area of then, would be this entire orange section. And I'm just going to go ahead and apply my formula. Oh, I'm being asked to find the radius of the circle. That's our missing value. So I know the area of the sector is equal to the central angle over 360 times pi r squared, the area. We don't know r, so the best we can do is put an r in here. Okay, so we're going to clean this up. First thing I'm going to do is reduce this by 5s for sure. So let's go, that goes in there 63 times, and 5 goes into there 72 times. And now we can see that 9 goes into both of those. So at this point, to make my life as easy as it can be, I'm going to go ahead and multiply both sides by 8, which creates 28 pi on the left and 7 pi r squared on the right. Then, and let's go ahead and make a note that that's what we did, times 8 on both sides. At this point, I'm solving for r squared, so I want to divide both sides by 7 pi, which leads to r squared equals 4, which leads to, of course, r equals 2. So your radius is 2 units, whatever they happen to be. Okay, let's go ahead and take a look at, I think we're going to stop. Oh, actually, we're going to go to the last page, page 4 from here. We're going to page 4. Okay, on page 4, we have a new vocab word. This is a segment of a circle, and you find the segment of the circle area by taking the area of the sector and subtracting the area of the associated triangle, which of course leaves you with the area of the segment. I like to call it the biscotti. Okay, so we're looking for the area of the shaded region in this picture, which, as you can see, the shaded region is this segment of the circle. So the sector that goes with it is this sector here that I'm outlining in blue. And then we're going to take away this triangle. So the area of the sector is going to be found by taking the central angle over 360 times the area of the circle, which is pi r squared. Okay, so that comes out to be 1/4 of 64 pi, which is 16 pi. Okay, the area of the triangle associated here, area of triangle is 1/2 base times height. Since this is bounded by 2 radii, the base will be 8 and the height will be 8, again, because it's a right triangle. So 1/2 of 64 is 32. And so now that we have those two values, we would say the area of our shaded region is going to be equal to area of sector, take away area of triangle, which is 16 pi, take away 32. And since we don't have any units, we're just going to say square units. Okay, we are going to stop there, and we will look at the remaining examples in class. Stay classy.